Hey, I want to do a video from section 3.1. It's about complex numbers, or what we call imaginary numbers. And then complex numbers is a combination of real numbers and imaginary numbers. So the idea is we don't know what the square root of a negative number is. It's undefined, right? But we go ahead and say, let's create something that's not real. It's imaginary. It's the square root of -1 is I. This is a number that has the property that when you square it, you get a -1 back, which is very, very unusual. So, I mean, there is no number that you square and get a negative back. Or is there? There's the imaginary number I. So when we say what is the square root of -2, what we do is we use a property. Let me show you the property that we're about to use for radicals. The square root of a times b is the square root of a times the square root of b. So what we're going to do is we're going to separate this into 2 times -1. We're going to write this as the square root of 2 times the square root of -1, which is that imaginary number I. So this number 1 here is the square root of 2I. All right. So let's skip down a little. So most of these are pretty straight ahead. All right, let's add some. So this is what we call a complex number. A complex number is a combination of real numbers and imaginary numbers. So we usually put the imaginary number in the back. A and B are actually real numbers. These are real, and there's a coefficient on the imaginary number I. So when we add two complex numbers, you just add the real parts together and you add the imaginary parts together. There's nothing real exciting here. -4 plus 7 is 3. 7i plus 6i, so just like 7 apples plus 6 apples is 13 apples, and you just say 3 plus 13i. All right, so complex numbers are not too bad. Let's see here. Let's do some multiplication with imaginary numbers. So square root of -16 times the square root of -4. So the idea again, where we you don't have to show all this work, obviously, but we're going to move the negative portion to the back. And so it's going to be the square root of 16 times the square root of -1 times the square root of 4 times the square root of -1. The square root of 16 is 4. That's an I. That's a 2. And that's an I. So 4 times 2 is 8. I times I is I squared. And I squared is not just anything. It happens to be -1, which is... Again, there's no real number that does that, but we have this imaginary number that gives you a negative back when you square it. So this is -8. Very unexpected. Okay, another example. Let's do it a different way. You could write this as -25 times -49. And here's where you have to be careful, because this looks like, so the two negatives kind of cancel and make a positive. Man, that's a little tricky. So let's go ahead and just go 5i times 7i. 5 times 7 is 35. I squared is -1, so you get negative 35. Last kind of a few problems here are powers of I, and there's a pattern. Let me start the pattern for you. So you're looking for what? So I is obviously the square root of -1. I squared is -1. I cubed is negative. I to the 4th is negative I squared. Now, I squared is negative 1, so I to the fourth is actually positive 1. So when then you get to the I to the fifth, you're back to I. So this is the pattern. You start with I, it goes negative 1, negative I, 1, back to I. And so this repeats, this pattern repeats every 4 values. So all we have to do is rewrite I to the 19th as something like this. So here we go. What you want to do is think of this as I. Well, if you pull off one I, then you get I to the 18. All right. Now how can you write I as something we know? How about we write this as I squared to the 9th? Anyway, this is one strategy, is just write it as something we know. Now we know I squared is negative 1, so this is negative 1 to the 9th. Negative 1 to the 9th is negative 1, so this is negative I. So that's one strategy. There's other strategies on kind of sorting this out, but this is negative I. All right. I to the 19th is obviously the same one. So another strategy, I-24, what you do is you say, how many times does 4 go into 24? Well, it goes 8 times. Oops, sorry, it doesn't go 8 times. It goes 6 times. So you could rewrite this as I to the 4th to the 6th. Right? And I to the 4th we know is 1. So this is 1 to the 6th, which is 1. Okay, so I to the 24th is 1. Let's do one last one, and then we'll call it a day on this video. This is negative 1 to the 70th power times I to the 70th power. Now, you've got to know that exponents, they hit all the factors in the parentheses. So that's really important, because you got to know that turns into a positive 1. So positive 1 times, and then we got to rewrite I to the 70. Now, how many times does 4 go into 70? Well, it doesn't go evenly, does it? 4 goes into 7 once with 3 left over. How many times does 4 go into 30? Well, 7 times. 28 with 2 left over. Okay, now let me just show you what we're going to do here. So what we're going to do is write this as I to the 4th to the 17th power times I squared. Okay, now look at this carefully. I to the 4th to the 17th. What I'm doing here is 4 times 17 is 68. This is I to the 68. I squared. I mean, that adds up to I to the 70. So I'm breaking it down into things I know. I know that is a 1. So it's going to tell us right away that we have 1 times 1 to the 17th power times minus 1. And so overall, negative 1. All right. Thanks for watching.